Hello everyone. Welcome to week 4 session of digital electronic circuits. And today we will be discussing some of the questions that may help you in your assignments this week and also for your exams. So I'll wait 2 more minutes since nobody has joined, else I'll be recording this lecture and uploading on YouTube. Okay, so I'll start now. So the first question is number of selectants required in a 1:n demux is. Okay. Before that, we will look at what is mux and demux. So a multiplexer is something, we draw it something like this. It has multiple inputs, let's say n inputs, one output, and select lines, 2 to the power n inputs, and one output. This is a multiplexer. And for this one, here are two select lines, 2 to the power 2 equals to 4 inputs and one output. So we call it, let's say, S1, S0, and let's say A, B, C, and D. This is output Y. How it works is, and we call it 4 cross 1 mux because there are 4 inputs and one output. So how it works is that, okay, so we draw a truth table as 0 as S1 as 0. So this is MSB, this is LSB. So 0, 0, 0, 1, 1, 0, 1, 1. Y is the output. So 1 as 0 as 1 is 0. Output will be A, B, C, and D. This is how a mux works. Okay, so it is multiplexing 4 inputs into a single output. That is a multiplexer. Similarly, a demultiplexer, or in short called demux. So what it will do? So here we had 4 is to 1, right? We will have here 1 is to 4 or 1 is to 2 to the power n. Okay. So again, how it will look like? It will look something like this. Input, 4 output, select lines. Okay. So yeah. So again, S1, S0, let's call it Y1, Y2, Y3, Y4. So how its truth table would look like: S1, S0, 0, 0, 1, 1, 0, 1, 1, Y1, Y2, Y3, Y4. Here, this will get I1, get I, this will get I, and this will get I. So this is a 1 cross 4 dmux. So now the question was number of select lines required in a 1 is to n dmux. Okay, so if number of inputs we know is 1 in dmux, number of output equals to n. And earlier we saw if there are here if there are n select lines, there were to the power n output, right? So here they are saying there are n output, then number of select lines are log 2 base n, right? That is C. This is the correct answer. Okay, so this is our dmux. Okay, so let us look at the next question now. Find the canonical POS expression of FABC for the following figure. Okay, just a minute. So this is what we have. I'll draw it. Okay, let me draw it. So I'll draw the truth table for this mux. I already explained what is mux, so those who have joined right now, I'll tell again. So this is a mux. So it has multiple inputs, 4 in this case, 2 select lines and 1 output. Okay, so depending on the select lines, S1 and S0, it's 0, 0, then A will pass to the output. If it's 0, 1, this will pass 1, 0, this will pass 1, 1, this will pass. Okay, so this is simply a mux. Okay, so here what we can write it as, okay, so y equals to what? S1 bar, S0 bar A plus S1 bar, S0 B plus S1, S0 bar C plus S1, S0 C. So D. This is clear from this table, right? Now I've written it. The next question is based on this only. We will look at the, we'll just have to make this kind of expression. So here what we have is, so let me write it, B, C, F. Okay, let me give it inputs 0, 0, 0, 1, 1, 0, 1, 1. When it is 0, 0, then this A will pass, that is output will be A. When it is 0, 1, A bar will go. When it is 1, 0, this 1 will go. This 1. And when it is 0, when it is 1, 1, 0 will go. So it is 0. Okay, so what have been asked is we have to find the canonical POS expression for FABC. Okay, so from here we can write what is F. Okay, let me copy it here. So here what we will get, F equals to B bar C bar A. I'll write it as ABC. A B bar C bar plus A bar B bar C plus, okay, so this is what, just A will be 1 dot B C bar plus 0, then that's always 0. Okay, so, so this is the expression that we have for F. Now, okay, now we have to identify the min terms for this. Okay, So for A, B, C, 0, 0, 0, 0, 0, 1, we know counting will be from 0 to 7, right? That we have to identify what these literals are. So it is what's sigma m. This is what 1, 0, 0. 1, 0 is what is 4. This is what 0, 0, 1 is 1. And this is what 1. Okay. So here what we have is we have BC bar, right? So BC bar can be both A plus A bar. Okay. That's how we got this one, right? This one is what? A plus A bar. So this we can expand to A B C bar plus A bar B C bar. This is what actually 1 1 0 and 0 1 0. 1 1 0 is 6, 0 1 0 is 2. Okay, so we have, I'll just rearrange them. 1 2 4 and 6. Now this is in SOP form, right? For POS it will be pi m and all the remaining numbers, that is 0 3 5 7. Okay, so the POS expression. Okay, this is the final answer that we wanted to derive. So let me look at the participants. If anybody has any questions. Okay, so there are three participants, I suppose. Does any of you have any questions in this, or do you want me to repeat it? Please write yes or no in the chat if you want me to repeat it. Okay, so there is not any problem, Gauri says. So let us move ahead. So I hope you can do questions like this, where inputs are given in this form to identify the outputs. Anyways, so let us look at the next thing. So if you guys do have any questions, please feel free to use your mic or just drop a message in the chat box. I'll be looking at those and I'll answer your queries. So, okay, the next question is we have to find the uh, in the following circuit diagram the propagation delay of multiplexer, NOR gate, inverter, and this. If input PQ RST are applied at the same time, calculate the maximum possible propagation delay in nanoseconds to the output Y. Okay, so we have been given, we have to find the propagation delay for output Y. Okay, so let us take uh, a multiplexer. It is 2.5. So let me write 2.5 nanoseconds, 2.5 nanoseconds. It is 4 nanoseconds for this NOR gate, 4n, 4n, and 2 nanoseconds for inverter, 2n. This is not required, but fine, 2n. Okay, so we'll have few cases. First is take when t equals to uh, let's say t equals to 0 first. Okay, so in t equals to 0 case, what do we see the propagation delay? So when t equals to 0, this is 0. This will take 2 nanoseconds, but it will become 1 here, okay? So let me write it first. So after 2 nanoseconds, it will be 1. Here it will be 0 instantly because there is nothing here causing delay. So when this is 0, so this will pass. So for this Q and R, 4 nanosecond will take. So this delay will come 4n. Then multiplexer delay for 2.5n. So let me write y delay 4n plus 2.5n. Till here we have 4n plus 2.5n. Now if you see, this 2n will be absorbed in this 4n 2.5n. So until we get this output, this 2n is already over, right? We have this 6.5n nanoseconds already taken by this stage. So this multiplexer will already be on by that time. Okay. So then this input will go here in this NOR gate. We will take another 4n. 4n. Now if we see what is the output here, it is 1 after 2 nanoseconds. So when it is 1, this will propagate here. Okay. So this 4n actually won't be here because this output is 1. So only directly this, and this path will go. This won't come into picture. So this 4n won't come. Instead, this 2.5n will come. That is total 9 nanoseconds. So I'll repeat it once more. So let's say at t equals to 0. At t equals to 0, we apply a 0 here. So at, let's say, t equal to 2n, we will have a 1 here. At t equal to 4n, we will have some output here. And at t equal to 4 plus 2.5n, that is, let me write it, 6.5n, we will have some output here. Now already at t equal to 2, this is we here is 1, so this select line will turn this input line on. So as soon as this 6.5n comes, this will go in here, and this after 2.5n delay, we will get this output y. So output is, so we will get this output at y at 6.5 plus 2.5 equals to 9n when t equals to 0. Okay. Now let us see for t equals to 1. So let me erase these things. So now when t equals to 1. So at t equals time 0 seconds, here it is 1. Okay. And after t equal to 2 nanosecond, here will 0 will go. So after 2 nanoseconds, this is turned on. And here instantly this is turned on, right? So here there is no delay for this turning on, but here is 2 nanosecond delay. Now after this, a 2 nanosecond delay will occur, and this input will reach here. So we have this 2, then this 2.5 for this mux output, then it is 0, this 4n, then this 2.5n. Okay, so let me rewrite it. Y delay to 2n. So this, since instantaneously this will turn on this as this input line. So you have 2n delay from here. So 2n I have written plus 2.5n delay of, so after this 2.5n delay of passing this through mux. So this 2.5n. So I'll write plus 2.5n. Now we have done this and this. Now this select line is on, right? So 4n delay of here plus 4n. So till now we are here, here, and here. Now 2.5 delay for passing through here plus 2.5 this will give me what? 2.9, 10, 11. So 11 nanoseconds. So the maximum possible propagation delay is 11 nanoseconds. Is there any doubt in this part? Okay, so I suppose there is no problem. If there is, please feel free to write in chat or use your mic. Okay, so let us go to the next question. Let's read the question for a moment. So here, what we have today is we have been given a 4 cross 1 mux and we have to implement this q equals to xy plus z. Where x is MSB and z is LSB. Use this select length and input variable. Okay. So we have to find the input conditions to get q equals to xy plus z to implement this function. Okay. So let us do one thing. Okay, let me just try to solve this. We have to implement what? Q equals to xy plus z. And we have a 4 cross 1 mux only. We have this. So, okay. Here it is Q that we know. So let us take x and y here as select lines. We will have some conditions of z here, right? Z1, 0, something like this. Okay. So, yeah, we can write it D0, D1, D2, D3. Okay. So, what we have is xy plus z. So let me just write its min terms. So what we have to do is we have to make write its min terms. So how do we do that? So since it has three variables, what we will do is so xy plus z will be xy z plus z bar plus z x plus x bar plus sorry y plus y bar. Okay, this simply I've written this is one and this is one, this is one. I've just multiplied one all the sides, right? So if I write this, it will be xyz plus xyz bar plus xyz again. So I'll not repeat it, it's already here. So plus x bar yz from this term, x bar yz. Okay, so we have done this. Then x y bar and z, y bar z plus x bar y. X bar yz is done. Y bar and z is done. Let me see all the combinations if they are done. X, Y, Z, X bar. Okay. One is left. X bar, Y bar, and Z. Okay. So what are these now? 111, 110, 011, 0. 1 0 1 0 0 1. Okay, so this is what 7 6 3 4 5 1. So we have sigma m 7 6 3 5 1. Okay, so now what we will do is we will make a table. We have to do sigma m 7 6 3 5 1. Okay, so what do we have? X, Y, and Z. Okay, D0, D1, D2, D3, Z bar, and Z. Okay, so this side is this. Then it is what? X bar, Y bar. So when it is X bar, Y bar, right? When it is X bar, Y bar, that is 0, 0, then only D0 is selected, right? That's why I have written here D0 below X bar, Y bar. Similarly, X bar, Y, X, Y bar, X, Y. Okay, zeros. So now this is what 0, 0, and this is 0. So 0, 0, 0 is 0. This is 0, 1, 0. 0, 1, 0 is what? 2. 1, 0, 0 is 4. 1, 1, 0 is 6. 0, 0, 1 is 1. 0, 1, 1. 0, 1, 1 is 3. 1, 0, 1 is what? 5. And here 1, 1, 1 is 7. Okay. These are the numbers that we have. Okay. And now out of these we have what? 1, 5, 3, 6, 7. So we'll encircle them 1, 5, 3, 6, and 7. So this will give us the outputs at that we have to give. So at D0 we have to give Z output, D1 we have to give Z, D2 we have to give Z, and D3 we have to get both Z plus Z bar. That is 1. Okay, Z plus Z bar. So this is how our mux will look like. D0, D1, D2, D3. Here we will give X and Y, Z, 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 and 1. And Q will be xy plus z. So is this question clear or do you want me to repeat it? This was the condition that we had to find. This A should be the answer. So I'll repeat the steps again anyways. So first is we have the function that we have to implement x equal q equal to xy plus z. Then what do we have to do? We just need to expand it into its standard canonical. So first is expand to standard SOP form. So here we have expanded it to standard canonical SOP form. We have, sorry, here we have 1, 2, 3, 4, 5, 5 terms here. After that expansion, second step is write the min terms required. Those are here. Okay. Now next is just choose which will be the select line. So since in the question options were given as Z, Z is going as the inputs here. Z is input variable and X and Y are select lines. X and Y are here. So next is we draw the table. So what third is draw table between input and select lines. So here and Z bar could be the input and X, Y are the select lines. So how do we draw this table is just write X, Y and Z here. So how X and Y vary and how Z vary, those combinations are the numbers that we will get, right? And what T are we using? This form, right? X, Y, Z, that is 0, 0 is X bar, Y bar, Z bar. 0, 0, 1 is X bar, Y bar, Z, similar to this, and 0, 1, 0 is X bar, Y bar, sorry, X bar, Y, Z bar. Similar to this. So here what we have X bar, Y bar, Z bar, that is 0. If we have X bar, Y bar, Z, then we have 1. Similarly, X bar, Y, Z bar, that is 2. 0, 1, and Z is 0, that is 2. And X, Y bar, if we see Z bar, X, Y bar, Z bar is what? 1, 0, 0, that is 4. That's why I've written 4 here. X, Y, Z bar is here, so Z bar is 1, 1, 0, that is 6. And this side, X bar, Y bar, Z. X bar, Y bar, Z is 0, 0, 1, that is 1. X bar, Y bar, Z is what? 0, 0, sorry. X bar, Y, Z is what? 0, 1, 1, that is 3. X, Y bar, Z is 1, 0, 1, that is 5. And X, Y, Z is 1, 1, 1, that is 7. So after we have written these numbers, we just encircle those that are there in our minterm 7, 6, 3, 5, 1. Then it's 7, 6, 3, 5, and 1. Now here what we have, whatever corresponding to the row we have encircled, we will just write this. That will go as the, whatever we are writing here will go as the input to this D0, D1, D2, D3 in this mux. Okay. So here since Z corresponding to Z1 is encircled, we will give Z. Here 3 is encircled, then Z. 5 is encircled, Z. Both 6 and 7 are encircled, that means both Z bar and Z. That is 1. Z bar plus Z is 1. So there 1, we will give 1 here. That is all I have given here. So I hope it is clear. If not, please let me know. So the important thing here is to remember how to write the table. It is fairly easy, but just you need a little bit of practice for that. So please do that. Okay. So uh, let me see if anybody has any questions. Okay, there are no questions. I hope you guys are following. If not, please do let me know, and I'll repeat any problem that you want. Okay. So okay. Let me move on to the next question then, if there are no questions. So the question is, this is an 8 cross 1 mux. It has 8 inputs, 1 output, and 3 select lines. Okay. So something is implemented already here, and we have to find what is the output. So this is easy. Okay. So what we have to do is we just have to write the expression for y. You can already see what is there. So this is 0, D 0, D 0 0 1 0. Okay, so this will be when it will be A bar B bar C bar, A bar B bar C, A bar B C bar, A bar B C, A B A B C bar, A B A sorry A B bar C bar, A B bar C, A B C bar, A B C. This is how it will go, right? And it is like A bar, B bar, C bar, or 0 0 0. Then this I0 will be selected. And it is 0 0 1. I1 will be selected. 0 1 0. I2. Similarly, 1 1 1. I7 will be selected. Okay. So let us just write the outputs. So let us write. Okay. So when it is A bar, B bar, C bar, output is 0. So it is 0. So multiplied by 0, it will go away. Plus A bar, B bar, C. When it is A bar, B bar, C, input is D. So we will multiply D here. Plus again, so I'll not write the zero terms anymore. This won't give anything, this won't give anything, these two won't give anything. So we are only concerned with this. Okay. So I'll write here, this is A bar B C, and we will have D as input. Plus A bar B C D, plus, and we have A B C bar, we have 1. Okay. So A B C bar, we have 1. So I'll expand this 1 as D plus D bar. So what I will get, so if I write this term only, it will be expanded as AB C bar D plus AB C bar, sorry, C bar D bar. Okay. So now I'll just write the numbers corresponding to those. This is what 0 0 1 1. This is what 0 1 1 1. This is what 1 1 0 1 and 1 1 0 0. 0 0 1 1 is what 3. This is what 4 5 6 7. This is 8 9 10 11 12 13, and this is 8 12. Okay. So what do we have is sigma m 3 7 13, 12 and 13, and this is the answer. Okay, is this clear? So, okay, so I hope it is clear. What we have to do is just look at all the input cases 0 0 0 0 0 to 1 1 1, and wherever there is some input except 0, just write the output for that and find the minterms, and that is the answer. Okay, so let us read the next question now. Okay, so it is a similar question to previous one. We just have to find the input questions. So let us see. We have to implement what? F equals to A B plus C. So I'll just expand it. First step is write POS, sorry, SOP. So I'll just expand it equals to what? AB plus AC, and we have what D also, so it will be AB C plus C bar. Uh, yeah, and this will be what? Plus AC, A B plus B bar C. This is what? ABC plus ABC bar plus ABC is same, so I'll not rewrite it, plus AB bar C. Okay, so when A is 1, B is 1, C is 1, F will be 1. So let us look at that part. So here A is 1, B is 1, and C is 1. So this part is this. So here D7 should be 1. Next is A is 1, B is 1, and C is 0. Next I'll choose different color. A is 1, B is 1, and C is 0. Okay, sorry. A is 1, B is 1, and C is 0. This should be 1. Then A is 1, B is 0, and C is 1. So A is 1, B is 0, and C is 1. So this should be 1. Rest all should be 0. Okay. So all these terms, all these zeros. So where will D's go? This D will go here. Uh, D7, D6, D5. Similarly, other terms will have D4, D3, etc. But we do not want them. That's why these all D's should be 0. Only these D should be 1. That's why we are writing 1 here. So our input condition should be 0, 0, 0, 0, 0, 1, 1, 1. Just this one. So this was fairly simple, I think. If you want me to repeat, please let me know. Okay, so I hope there is no problem in this one. So the procedure is same, just write the SOP form, expand the expression that you want, identify them in uh, the cases where A is 1, B is 1, and everything. Then just add 1 here. Those will give you the results. So let us go to the next question. So what we have to do this time is we have to simplify the Boolean expression for customized priority encoder given in table below. Okay. So now we have an encoder. Okay. So what does an encoder look like? An encoder has certain inputs, let's say M inputs and some outputs and one enable. So let here in this case this D1, D2, D3 are inputs. Let me write it like this. D0, D1, D2 and Y1, Y0 and V are outputs. Okay. So what we have to do is we just have to simplify. We just have to find the expressions of these all of these three outputs in terms of these inputs. That is simple that we used to do earlier also in previous questions. We just have to write the truth table for each of them one by one. So okay. So let me write. Uh, Let me copy it here. So okay. So for now, just okay. Let me just for now just forget these two. Just focus on this one output y1, y1. Okay. So then this y1 is 1. We just have to find those cases. So it is 1 here and 1 here. So what are the cases here? Y1 is 1. So let me write it again. En, D2, D1, D0. So y1 is 1 when En is 1. I'll just write this. D1 is 1. These both are cross cross. So cross cross can be both 0 and 1. So I'll write first 0, 0, 1, 1, 1, 1. For these cases, y is 1, y1 is 1. And similarly, if we look at this one, it is 1, 0, 0, 1. So this y1 is 1. So for these three cases, y1 is 1. Okay, not 3. Sorry, my bad. So since these are xx, right? But these are xx. So it can be both 0 and 1. So it can be 0, 0, 0, 1, 1, 0, 1, 1. So for these four cases, y1 is 1 and this additional case, this one, 1, 0, 0, 1. Okay, so let me just write the min terms for this. And yes, sorry, see my what is this? This is 8, 4, 2, 1. So it is 12. This is 13. This is 14, 15, and this is 9. So 9, 12, 13, 14, 15. So now if we draw a K-map for this, En and D2, let me write here, and D1, D0 here. It will be a 4 variable K-map. Okay. So 0, 1, 3, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is what? En bar D2 bar, En bar D2, En D2, En D2 bar. Similarly, choose another color. D1 bar D0 bar, D1 bar D0, D1 D0, D1, D0 bar. Okay, so we have 1 at 9, 12, 13, 14, 15. Okay, so we just make clear this is 1 and this is 1. So it is y1 equals to en d2 plus what is this? En d1 d1 bar d0. Okay, so it is what? En d1, sorry, d2 plus d1 bar d0. This is y1. So this is our final expression for y1. Similar things we will do for y2 and y3. So let us do one more, then third one I'll leave it to you. Okay. Now let us look at y2. Okay. So I'll hide these two so they don't confuse us. So y0. So y0 is 1 at this case. Okay. In this case it is these two. So en d2 d1 d0 is 1 0 1 x. So for x I'll write both 0 and 1. 0 and 1 1 0 1. So this was x case, right? X. And this one 1 0 0 1. For these y0 equals to 1. This is what 8 4 2 1. So this is 10 11 and 9. So for 9 10 and 11. So I'll draw a K map. D1 D0 D1 bar D0 bar D1 bar D0 D1 D0 D1 D0 bar En bar D2 bar En bar D2 En D2 En D2 bar. Okay, so we have 0 1 3 2 4 5 6 7 8 9 10 11 12 13 14 15. We have 1 at 9 11 and 10. 9 10 11. So what we can make is we can just make two pairs here, this one and this one. So y0 equals to en d2 d0 plus en d2 d1. So y0 is en d2, sorry, d2 bar, en d2 bar d0 plus d1. This is y0. So I'll just unhide this and I'll let you guys write the expression for v. So please, as soon as you write it, please write it in chat. I'll hide these two columns. So let us see if you understand anything. Please, this is the truth table. Write the expression for v. Please write it in chat as soon as you are done. Please let me know your answer. What is the expression for V? Mm, are you able to do it? If not, please let me know if there is any problem. Let me see what are here. Gauri, Mr. Jagannath Nayak, and Miss Hemlata. Are you able to follow? Or should I wait or I should move ahead? What do you say? Are you trying this problem? Okay, so since you guys are totally silent, I'll just move ahead. So I'll just write the answer. I won't solve for V. Write the answer that you should get, and you can try it on your own. V equals to En d2 d sorry, d2 plus d1 plus d0. Okay, so let us see. The answer is what? So this is the answer. Jagannath, okay. So I have given the example of 5 input K map in my previous class. So okay, so if you want me, I'll repeat it at the end of the class. So I'll solve two more questions, then I'll go to 5 input K map example. Okay. So the next question is design a 4-bit odd parity generator. Okay, using 4x1 multiplexer. Consider ABS select line. Okay. So first we should know what is an odd parity generator, right? So let's say we have here four inputs. It's 4 bits, so I'll take 4 inputs, B, C, and D, and our output is Y. So what are all the 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 0, 1, 1. I'll write it in the next page. Don't fit here. 100, 101, 110, 111, and again 000, 0 and 1, 2, 3, 4, 5, 6, 7, 8. Okay. Let me write it again clearly. 0000, 0001, 0010, 01110. Sorry, 011, 100, 0101, 0110, 11, 1000, 1001, 10, 1011, 1100, 1101, 1110, 1111. So now, since it is an odd parity generator, wherever we have odd numbers, an odd number of ones, odd parity generator, whenever we have odd number of ones, it will give 0 output. Even number of ones, it will give 1 as output. Okay, this is the thing that you have to remember. Odd number of ones, it will give 0, or even number of ones, it will give 1. So what does that mean? So we have 0, that is even number, so we'll write 1. 1 is odd, 1 is odd, even, odd, even, even, odd, odd, even, even, odd, even, odd, odd, even. Okay, this is how an odd parity generator will have the truth table. Okay, so now we will just draw a k-map for this. So we will have a 4 input k-map, 4 variable k-map. Right, A, B, C, D, A bar, B bar, A bar, B, A, B, A, B bar, C bar, D bar, C bar, D, C, D, C, D bar. Okay, so now we are saying that A, B are select lines, right? So A, B are select lines. So what is in a multiplexer, right? So A and B are select lines. So let's say inputs are I0, I1, I2, I3, right? And some combination of C and D is going here to give this Y. Okay, so I'll just write it like this. So when it is A and B are 0, 0, and A and B are 0, 0, output will be in the I0 select line. And when A and B are 0, 1, it will be in I1. So I'll just write it like that. I write it as I0, I1, I2, I3. Okay. So anyways, now let us fill it with numbers 0, 1, 3, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so now we just fill the ones. So let me write number 0, 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15. So we have 1 at here, 0, 3, 5, 6, 9, 10, 12, and 15. So let me fill it 0, 3, 5, 6, 9, 10, 12, and 15. So now Now I'll just write I0. So this row is corresponding to I0, right? So what inputs I should give to I0 is this one. Then so I0 is C bar D bar plus CD. I1 is C bar D plus CD bar. I2 is C bar D bar plus CD. I3 is C bar D plus CD bar. That is, sorry, C XOR D, C XOR D, C XOR D, C XOR D. That is the answer. C XOR D, sorry, C XOR D, C XOR D, C XOR D, C XOR D. That's the answer. So I'll repeat what we have done. First, we write the truth table for the odd parity generator. Wherever there are odd number of ones, so like this 0001, there is only single one, then the output is 0. And even number of ones, the output is 1. Then we made a K-map for that. Here we know it is a multiplexer, right? So we just have to send the out. We just have to tell what are the inputs here, such that we implement this odd parity generator. So that inputs are nothing, just the select lines will tell us what are the inputs, right? When it is A bar B bar, the input will be I0. When it is A bar B, the input will be I1. So like that. So we just tell what should be I0. So I0 should be C bar D bar plus CD depending on these ones, and we just write it for all four of them. And this is XNOR, this is XOR. So I hope this question is clear. If not, please let me know. I'll repeat it. Okay, so since there are no questions, let us move on to the next question. Okay, so the question is match the following. So data selector. So data selector will be multiplexer, since we select lines and we select the data, incoming data at the output. Serial to parallel conversion. So multiplexer is parallel to serial. Right, we have parallel inputs coming and serially we give them. But so opposite of that, demultiplexer will be serial to parallel. In demux, we have one input and multiple outputs depending on select lines. Okay, so BCD to 7 segment conversion. So here we will have a decoder, and signal to binary conversion is encoder. Like we had seen in that parity encoder, when we have what is a decoder and encoder. So in, let's say, decoder or like encoder, okay. We have, let's say, some inputs, enable, and let's say A and B are inputs, and we have multiple outputs, Y, I0, I1, I2, I3, depending on these 0, 0, 0, 1, 1, 0, 1, 1. this y0, y1, y2, y3. So depending on their condition, we will have some outputs. So 0, 1, 1, 1, 1, 0, 0, 0, 0, 0, 0, 0, 0. So when A and B are 0, let's say enable is 1 for all. The y0 will be 1. When A and B are 0 and 1, y1 will be 1. So this is kind of an encoder or a decoder, you can call. Okay. So anyways, so for signal to binary conversion, so if this is signal, you're converting it into binary. Okay. This was just this, and the answer will be C. Okay. So next question. Okay. Please read the question once. So we have to implement these functions using decoder, and we have to tell how many, uh, what kind of decoder and how many OR gates are required. So let us do this. So one thing that we can see is from seeing the numbers only 14, 11, 7. These will come. That is, we have three. Sorry, yeah, sorry, four variables, right? Then only we can get to this 14 or 11 number. That is uh, mod 16, right? So when we have like A, B, C, and D, four number, then only we can get when only we can get this 10, 11, 12, 13. 10 is what? 1, 1, 0, 0, and 11, 1, 0, 1, 1, 1, 1, 1, 0, 1, 1, 1, 1, 10, 11, 12, sorry, 0, 12, 1, 1, 0, 1 is 13. These we can realize when we have four variables, first of all. Okay, so now if we have four variables as input, so in a, as we discussed just here, sorry, decoder. So decoder, what we'll have, decoder B, C, and D. So we have n inputs, then we have 2 to the power n outputs in decoder. So we'll have 16 outputs, y0, y1, y2, dot dot dot, yn, y6, y15 here. So if it is 0, 0, 0, 0, only y0 will be 1, rest all will be 0. We have 0, 0, 0, 1, only y1 will be 1, rest all will be 0. Similarly 0, 0, 1, 0, this y2 will be 1, rest all will be 0. And at last 1, 1, 1, 1, all will be 0, last one will be 1, y15. So this is will be the truth table for decoder. So in this way, we can implement any function. So what this will give us, like, we will have possibility of all the sigma n from 0 to 16, sorry, 15, right? And so that is clear now that we will need a 4 cross 16 line decoder. Now how many OR gates? Since we have to implement 3 functions, we will need 3 OR gates, right? So our answer will be this. So let us take an example here. Let's say F3 we have to implement 2, 4, 5, 6, 7, right? So let me write it. A, B, C, D, Y0, Y1, Y2, 3, Y4. So, okay, so I know this already. Okay, I don't need to draw this. Let's say B, C, D are some input, and I'm getting Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7, Y8, and now I'm not writing on Y15. Okay, so now it says 2, 4, 5, 6, 7. So 2, 4, 5, 6, 7. All these will go in an OR gate to implement F3, right? Similarly, 1, 3, 8, 10, 11. So if I take 1, 3, 8, and let's say 10 and 11 are here, 10 and 11, another OR gate, I will implement F2. And similarly, for these numbers, I can implement F1. So another OR gate will be here to implement F1. So this is how this works. We will have a 4 cross 16 line decoder and 3 OR gates to implement these 3 functions. Okay. Okay, so these were the questions in the tutorial. So I'll just now go to that 5 variable K map question that you were asking. So let me see. I solved it last week, I think. So I have that 5 variable K map. Okay, so this is the question, right? Simplify the SOP expression using 5 variable K map. Jagannath, I'm solving your question, so please pay attention. This was the first question in the last assignment that I had solved. So it says we just had to simplify using 5 variable K map. So how do we solve a 5 variable K map is we, okay, so we know how to solve a 4 variable K map, right? So it looks something like this. Right, let me see. Let me take 4 variables as B, C, D, and E. Right, so I'll take B, C here and D, E here. So B bar, C bar, B bar, C, B, C bar, B, C. Sorry, I wrote it wrong. B, C, B, C bar. Here, D bar, E bar, D bar, E, D, E, D, E bar. Okay, so here I can form any combinations of B, C, D, and E. Now what is missing for 5 variable? A variable is missing, right? So what we do is we draw 2 such K maps. So I copy this here, paste it here, and shorten it. Yeah. So one I take for when A is 0, that is A bar case. One I take for when A is equal to 1. case. Okay, so this is what I have done. I have taken two K maps. So okay, so let me solve this question again. I'll copy this whole page. So okay, let me copy this. Let it be. Maybe. Yeah, copy. I'll erase the already fillings and I'll fill them again. Okay, so I said I draw two K maps, one for A bar and one for A, right? That is equal to 0, equal to 1. Now, if I write, I have to fill the numbers, right? So how do we fill numbers? When A, B, C, D. So when A bar, B bar, C bar, D bar, E bar, sorry, E also, then it is 0. So we here A here for all these 16 blocks, we always have A equal to 0. That is A bar case. So numbering we will have like this only. So 0 here now A bar, B bar, C bar, D bar, E bar. So sorry, A bar, B bar, C bar, D bar, E. That is 1. Then A bar, B bar, C bar, D, E. That is 3. Then A bar, B bar, C bar, D, E bar. That is 2. Similarly, just how you used to fill 4, 5, 7, 6, 9, 11, 10, 12, 13, 15, 14. Sorry, 15, 14. Okay, so after 15, now what? Here, now for each term, it is A. So A, so here we have A, B bar, C bar, D bar, E bar. That is, so it is what? 16, right? 16, 8. If we write the weights, 16, 8, 4, 2, 1. These all are 0, 0, 0, 0, 1. That is 16. Here 16 will come. So here next one is A, B bar, C bar, D bar, E. Is this one right? A, B bar, C bar, D bar, E. That is 1, 0, 0, 0, 1. That is 17. So here 17 will come. Similarly, we fill it 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Okay, let me erase these things. So now what we have is M0, 1, 0, 2, 10, 11, 13. So these we have to uh, fill it. So I'll just fill them 0, 2, 10, 11, 13. So till here will come first K map 0, 2, 10, 11, 13, 16, 18, 24, 26, 29, 16, 18, 24, 26, 29, and don't care conditions. Jagannath, okay, so you asked in PDFs. PDFs are available that I have, I think a sheet would be shared with you, a Google sheet. There you can find the links for all the videos and the PDFs also. I'll share the link in chat also. Let me see if I have it. So here are the PDF links. You can find the YouTube videos also, as well as the these recorded YouTube videos itself, and as well as uh, the Google Sheet and the PDFs that we use for all the three TAs. Okay. Don't get we have 5, 6, 9, 14, 21, 22, 23. 5, 6, 9, 14, 21, 22, 30, 21, 22, and 30. Okay, cool. So, okay, so it was also there. It is there. It is also there. Okay. So now we have to make pairs. So pairs and everything that we make. So here these corners can be combined into one. That is new thing how we make pairs. These four and these four can be one single group we can call it, and this will correspond to what is this, C bar and E bar, right? C bar, E bar. You see C bar and E bar is common for both. C bar here, C bar, E bar for this, C bar and E bar for this, C bar and E bar for this, C bar, E bar here. Similarly, C bar, E bar, E bar, C bar, E bar, C bar, E bar. For this whole yellow group is C bar, E bar. Okay. Now that is done. Other is this. What we can have is this. Let me choose another color. This would be another. This will be A bar, B, C bar, right? And another group we can have is, let's say, choose another color. This. This is what? A bar, B, C. Uh, Sorry, but C is not defined. A bar, since it is for A bar K map. B is common, so I'll write B. And then this D column, D bar E column, so I'll write D bar E. Okay, so one more is left, that is this one. So this we can write as A, since it is A K map. C is common here, so I'll write C. Then this row is D bar E, I'll write D bar E. So our F equals to C bar E bar plus A bar B C bar plus A bar B D bar E bar, sorry, E plus A C D bar E. Right, that is what I had written last time also, maybe. Okay, so last time I had done something about. Okay, let me do that also. So this can be reduced further. How? Let me not write this. So if we take this one in both, they both can be common. This will correspond to what? A, C, D bar E. So A bar C, D bar E. So if we have A bar C, D bar E, this A bar and A will be common. C, D bar E. A plus A bar, it will be 1. So we have C bar E bar plus A bar B C bar plus C D bar E. This is F. So this is how we solve this K-map, 5 variable K-map. So the thing to note is just we can group corresponding pairs in both K-maps together. Like this one and this one was common, so will just write the common term, that is C D bar E. Here these four and these four were common. We will write it just as it is. That is C bar E bar. Here there was nothing common, so I just wrote it as it could be A bar B C bar. This is how we solve a 5 variable K map. Are there any doubts? Okay, so if you have any doubts, please let me know, else we will close the session today. I'm not going to solve any more questions today. These were all the questions in
Hello,
your
sir.
mind. Yes.
I have one doubt in the week 5 assignment. In that
Okay.
that binary numbers which are in a two's complement form, that
Hmm.
is multiplied, and the results are shown in four options. But what I've seen in YouTube videos and all, after multiplying 4 with 4, it will become 16 bit. But here 8 bit, both are multiplied, but still it's the result is 8 bit. I didn't get how it's multiplied. Can you just solve once,
Which
multiplying
question
both?
is it? Sorry,
Uh,
I've not solved it yet, so can you please let me know which question is it? I'll try it.
it is, one second, sir. It is sixth question. Sixth question. Both A and B are 8 bits, and that to two's complement representation. The sign two's complement representation after multiplying A and B. So there is the answer we have to find out. But after multiplying, the result is remaining in 8 bits only. How to multiply two's complement, say signed numbers?
Okay, let me check.
Sixth question. Hmm.
Okay, so I do not have that exact question, but I have a similar question. So A is 11111101 and B is 0000 and 1010. These are two signed two's complement representations. So
Yes, yes.
this corresponds to what does this correspond to? So okay. So first of all, this is signed and two's complement. So we know since this is one, it is a negative number. Now its two's complement we can write is, so now it's normal form. So it is already in two's comp. We need to convert it into normal binary to know actually what this number is, right? So that is one, 1. 0, 0, 0, 0, 0. So it is minus 3, right? This number corresponds to minus 3.
Yes, it's -3. Yes.
And this one should correspond to what? Okay, let us see.
To get back to the normal number, the two's complement, again we have to convert into one's complement and then we have to add one to that. We'll get that normal back
Yes,
that
yes,
number, right?
yes. So another shortcut for getting, sorry, another shortcut for making anything two's complement is that, let's say you have any number 1101, or let's say 0010. So to make it to two's complement, you just see, uh, you start from left side. If there is a zero, just write it as it is. If there is first one you encounter, write it as it is. And after you encounter the first one, just invert all the digits. 110 100. So this is the two's complement for this. I'll give another example, like it is 1011. Okay, so you encounter the first one, write it as it is. After that, just invert all the digits. 010. This is the two's complement for this.
Okay, okay.
So this is a shortcut, but yeah, that also works. You find one complement and then add one. Okay, so uh, find two's complement number of A cross B. So B 0 0 0 1 0 1 0. So this corresponds to what? So B could be what? 0 1 1 0 1 1 1 1. Right? This could be B. And what is this? 0 4 2 1.
I think it's 146 or 246. 246 it will come.
Let's say it's 246. Just a minute. Okay, so we are doing what? 246 into minus 3. So definitely, okay, what is 246 into minus 3? And then even solve 46.
700 plus it will come. I forgot that number. I did it.
Okay, so if you do 700, it can definitely, it won't come in 8 bits. 700, we can only, how many numbers can we represent here? I think 255 only, right?
Yes, and answer is in only 8 bits. But 700 it will exceed 8 bits.
Yes, yeah,
So
that is correct. Yeah. So,
no, what I'm asking you is, sir, can't we directly multiply two bits which are in two's complement?
no, I don't think so. We cannot do that.
Like 1 into 1, 1,
No,
1
no, no,
into
no,
0,
no,
0.
no. That does not work like that. Uh, so let me search. Okay, let us see how do we do binary multiplication. I do not remember it. Okay, so according to this, we can do that, but I'm not sure about it. I've never used this technique. Always used to convert it to decimal and then do that. But here, what they're saying is if we have 10111 and 1101 to multiply, we do it like we do normal multiplication. Multiply this by all this, so it will be just 11101. Then leave this space here. Then 00000 11101 11101. What to get 110100001. Have I done something wrong?
So this will increase the number of bits, no? When you
Yes, yes.
multiply 4 bits into 4 bits, it will become 8. So 8 into 8, it should become 16 bits.
Hmm. Actually, not necessarily, but yeah, it can become if the numbers are big, but not necessarily. So if we have 8-bit numbers, let's say 00001111 and 000010, or any number, let's say simple number, let's we take 0010. So this is what, just 2 and 15. 2 into 15 is 30. We can easily represent it in 8 bits. So it just depends on the multiplication that we have. It depends on the two numbers that we have. If the final result could fit in 8 bits, definitely we can do that. If it does not, then we obviously have to add the additional bits. It is not necessary that we will always have 8 bits cross 8
Okay,
bits will be
okay.
16, right? Not necessarily 16. Just depends on the numbers that we have to multiply. So I will look at that question. So I have not looked at that assignment yet. So if you still are unable to solve that, please drop me an email or you can comment on the YouTube video also. I'll try to solve it and get back to you. Okay.
Can you please send your email
Yeah.
ID?
My email ID is at the top of every assignment. So this is my email ID. Let's go back there.
Actually, tomorrow is the last day to submit that assignment.
Okay. So I'll try to solve it today. You just drop me an email and I'll get back to you. Okay. And please, when you are asking any doubt in email, please send your solution, what you have attempted also, so I can look at it and see where you are making mistake. Okay.
Okay.
Yeah. So anything else today? Okay. So if we do not have any more doubts, we can stop here today. Okay. Thank you all for joining.